If more people knew that your graphene healthcare that everyone's all freaked out about is actually right here on the Frontier Chemical Journal, as in, everybody knows about it. That is, everybody except you. Biosensors are very common and they are made out of more than just graphene. We're going to read graphene-based sensors for human health monitoring. Since the desire for real-time human health monitoring, as well as seamless human-machine interaction, is increasing rapidly, plenty of research efforts have been made to investigate wearable sensors and implantable devices in recent years. As a novel 2D material, graphene has aroused a boom in the field of sensor research around the world due to its advantages in mechanical, thermal, and electrical properties. Numerous graphene-based sensors used for human health monitoring have been reported, including wearable sensors as well as implantable devices, which can realize the real-time measurement of body temperature, heart rate, pulse oxygenation, respiration rate, blood pressure, blood glucose, electrocardiogram signal, electromyogram signal, and electroencephalograph signal. Herein, as I review the latest graphene-based sensors for healthcare monitoring, their novel structures, sensing mechanisms, technological innovations, components for sensor systems, and potential challenges will be discussed and outlined. Now we're going to scroll down to the image, Figure 1. Brief of graphene-based sensor platform for health monitoring. A major distinction can be made between non-invasive and invasive applications, including wearable sensors for monitoring biophysical, biochemical, environmental signals, and implantable devices for nervous, cardiovascular, digestive, and locomotor system. Let's enlarge the image. On the left side, you have your invasive applications, and on the right, your non-invasive applications. They can take all the signals where it says non-invasive applications. Every single one of these signals they can measure with a drone over your home. Although graphene is the most talked about, it is not the only metamaterial in use of this. There are biosensors literally everywhere and in everything. You have a digital twin for your most recently deployed graphene healthcare. Now, we're going to look at the Graphene flagship website. Technology and Innovation Roadmap. Graphene flagship innovations pave the way to the market. And as you can see, this is funded by the European Union. The Graphene flagship's Technology and Innovation Roadmap demonstrates various paths that graphene can take to transition from lab to use in industrial applications. The roadmap aggregates a common view on graphene and related materials and offers strategic guidance for both the graphene flagship and the industrial uptake of graphene. The roadmap establishes a timeline for when one can expect graphene to be applied to different application areas and investigates the evolution and potential societal and industrial impacts of graphene and related materials enhanced technologies. The latest version of the Technology and Innovation Roadmap specifically explored 4 promising areas for graphene commercialization: supercapacitors, anti-corrosion, lithium-ion batteries, and neural interfaces. By expanding to new focus investigation topics, the Industrialization Roadmap team hopes to both explore and obtain a deeper understanding of diverse graphene applications, while fostering their impact on European industries. While the GRM market is expanding, there are still obstacles to growth. The outcomes of the roadmap work also show the lack of application-oriented and traceable material quality standards of graphene. This means the graphene flagship standardization efforts will be key to the success of graphene in the marketplace. Let's click on the lovely image. As you can see here, we have 2023 and before. In the composites section, we have functional coating and surface modification, structural materials. In the energy section, we have fast charging batteries, advanced photovoltaics, In the Datacom section, we have Advanced Long-Haul Optical Communication. In the Electronics, we have Low-Cost Printable Electronics. In the Sensors and Imaging section, we have photodetectors and physical chemical sensors, and broadband CMOS cameras and spectrometers. In the Biomedical Technology section, we have biosensors. Now we're going to look at the technology between the years of 2023 and 2029. In the Composite section, we have multifunctional construction materials and water treatment and desalination. In the Energy section, we have flexible perovskite solar cells, supercapacitors for logistics, perovskite multi-junction photovoltaics. In the Datacom section, we have advanced network infrastructures. In the Electronics, we have high-frequency electronics and flexible devices. In Sensors and Imaging, we have autonomous cars. And in the Biomedical Technologies, we have neural interfaces. Now we're going to look at 2030 and beyond. In the Energy section, we have fuel cells for transportation. In the Datacom section, we have 6G and beyond, wireless networks, and on-chip optical data. In the Electronics, we have high-frequency devices. And last but not least, in the Biomedical Technology section, we have drug delivery and bioelectronic medicine.
So do you think that this graphene was specifically put into the shot to help?
Absolutely, yeah, because the graphene is, well, it's one of the metamaterials that create the cyber-physical backbone. So they needed these, they needed this in people. They needed people to take the shots. So that's why they pushed it. That's why, you know, they literally were bribing people any way they could to just have them take it because they needed that. The system wouldn't function without its cyber-physical backbone. And the cognitive cities wouldn't function without it.
And they kept pushing more and more and more. Booster 1, 2, 3, 4, 5.
Oh, yeah.
So imagine just how much graphene.
Yeah. They were just trying to fill people with metamaterials. Again, it's for augmentation. Because if it's in you, it's outside of you. We can control you from the inside out. It's that simple. We are here with Science Direct, and we're going to read Graphene-enabled wearable sensors for healthcare monitoring. Wearable sensors and healthcare monitoring have recently found widespread applications in biomedical fields for their non- or minimal invasive, user-friendly, and easy accessible features. Sensing materials is one of the major challenges to achieve the superiorities of wearable sensors for healthcare monitoring. While graphene-based materials with many favorable properties have shown great efficiency in sensing various biochemical and biophysical signals. In this paper, we review state-of-the-art advances in the development and modification of graphene-based materials, i.e. graphene, graphene oxide, and reduced graphene oxide for fabricating advanced wearable sensors with 1D fibers, 2D films, and 3D foams, aerogels, hydrogels, macroscopic structures. We summarize the structural design guidelines, sensing mechanisms, applications, and evolution of graphene-based materials as wearable sensors for healthcare monitoring of biophysical signals. For example, mechanical, thermal, and electrophysiological signals, and biochemical signals from various body fluids and exhaled gases. Finally, existing challenges and future prospects are presented in this area. And for those of you who want to keep reading, there is lots of information on here. But for now, we're going to look at the IEEE conference so that you can get a better understanding that these people know exactly what they are doing and know exactly about the topics that I teach here on the channel. So we're here with the IEEE Biomedical Circuits and System Conference. And this was in 2023. The conference was held in Toronto, Canada. The 2023 IEEE Biomedical Circuits and System Conference is a premier international forum for presenting interdisciplinary research and development activities at the crossroads of medicine, life sciences, physical sciences, and engineering that shape tomorrow's medical devices and healthcare systems. This conference brings together members of our communities to broaden their knowledge in emerging areas of research at the interface of life sciences and circuits and systems engineering. The 3-day single-track program of BioCast 2023 is multidisciplinary with topics including, but not limited to, biomedical technologies, biosensor devices and interface circuits, body area sensor networks, and wireless healthcare monitoring, which is exactly what we've been talking about in the last couple episodes. Implantable and wearable health devices and systems, which we covered as well. Bio-inspired and neuromorphic circuits and systems. Electronics for neuroscience. Innovative circuits for medical applications. Biofeedback, neuromodulation, and closed-loop systems. Assistive rehabilitation and quality of life technologies. Biotelemetry and energy harvesting, scavenging circuits and systems. Lab on a chip, BioMEMS, point-of-care devices. Now we have biomedical applications. So we have artificial intelligence of things for healthcare, biomedical imaging and image processing, biosignal recording, processing and machine learning, genomics and systems biology, human-machine interfaces, medical information systems, and bioinformatics. Now in the emergent technologies, they covered COVID-19 diagnosis, flexible devices and circuits for biomedical applications, and brain-computer interface. Here on the channel, we've covered some of these topics. The ones that we haven't covered yet, we will be covering in the next few episodes. But as we can see here from their conference, they are very well educated and informed on these topics. Now, if we look at the image here, we can see they are changing around the frequency on the inside of the biosensors only. There is a lot going on with power, the electrical signal, the measurements, waking up certain nodes, closing other hoops or routing paths as they are no longer needed. All of this is happening under the skin. This article was released in 2015. Dynamic channel allocation for interference mitigation in relay-assisted wireless body area networks. It's a mitigation in relay-assisted wireless body area networks. So they are just passing their signal across you really fast because you're in the way and your body area network happens to be, by the networking of the system, more appropriate than others.